This is my video on polar covalent bonding. It should help you if you don't know what you're doing, where you're going, or if you have no clue what a polar bond is. So, one of the properties of elements which allows polar bonds to exist is electronegativity. Electronegativity is an atom's or element's ability to attract electrons. It increases as you move to the left and go up on the periodic table. Now, one of the most electronegative elements, or the most electronegative element on the periodic table, is fluorine. Fluorine is ridiculously good at attracting electrons, just like Justin Bieber is ridiculously good at attracting 13-year-old girls. But that's creepy. So, moving on from Justin Bieber, we're going to talk about electronegativity current. So, more polar bonds. Obviously, polar bonds occur between nonmetal atoms, like, again, hydrogen, fluorine, oxygen, hydrogen, which makes water, which I will tell you about later, which is a very cool element. Alright, molecule. I'm an idiot. Don't trust anything I say. I'm not wearing a stethoscope. So, hydrogen fluoride. Hydrogen fluoride is a very polar molecule. It has a very high electronegativity difference. Because fluorine is so good at attracting electrons, it creates a negative dipole at the end of them. And because the electronegativity difference is so great, the electrons really want to be on this side. They really want to be close to fluorine, which makes this end sort of a miniature negative dipole, and the hydrogen end a very positive sort of dipole. And I'll explain a few other things that actually kind of connect to this. It's very interesting. So first you have like this arrow that we use to indicate a polar bond, which is a plus kind of, which indicates the positive side and points towards the negative side. In this case, obviously, it's fluorine. Has a way higher electronegativity than hydrogen. They're pretty much on the opposite side of the periodic table. I mean, they are. Like, they're really far apart, which creates a very high electronegativity difference. So, you might be asking me, why aren't all bonds polar? Well, some are actually more polar than polar bonds, if that makes sense, in the sense that the electronegativity is very high, higher than 1.7. Anything higher than an electronegativity difference of 1.7 would be ionic. Anything lower than 0.2 would be a nonpolar bond. This is kind of the range of electronegativity difference between two atoms that would make a polar bond. So anything in here is polar. Anything that way, nonpolar. Anything this way, ionic bond. Polar bonds are usually covalent, nonpolar bonds are usually covalent, and these ones are ionic. Way over here. And those usually occur between metals and nonmetals, whereas polar and nonpolar bonds occur between two nonmetals because they're covalent bonds. Now, polar bonds are kind of responsible for all the cool properties of water. Water has one oxygen and two hydrogens. Due to the polar molecule, the arrow actually goes this way. This is the positive end, obviously, with the hydrogen. The higher electronegativity is oxygen, so the negative end moves this way. This makes water very good at being attracted to itself and dissolving things that are also polar. What'll happen is when you get another water molecule, they'll kind of hydrogen bond. Well, they will hydrogen bond, and they'll get attracted towards each other. And the way this works is the polar bonds want to line up with their little tiny dipoles that they create, the dipoles being the positive end here and the negative end here. This is very blobby water, I'm very sorry. And they'll kind of line up like this, and they'll make a little crystalline structure lining each negative dipole with the positive dipole, which gives water its surface tension and its ability to attract to itself and its density, which is a lot of the properties of water, actually. Polar bonds are also responsible, again, for hydrogen bonding, which, if it didn't exist, nothing kind of would. No life would exist. Hydrogen bonds hold together DNA, RNA, they hold together a lot of molecules. That's about all I really have to talk about, in a way. I need to check my paper here. I can go through them all. Where did I put it? Okay. So, to review, you learned that polar bonds are covalent, and they usually occur between two nonmetals. They share electrons unequally, creating a small dipole. We indicate which way the negative charge is by putting a positive arrow, kind of, with a little plus on the end pointing at the negative side. I will show you the hydrogen fluoride diagram again. See it? Got it? Memorize it? Good. Okay. What's so rad about fluorine? I have a lot of these. I needed a lot of these. It's the Justin Bieber of the periodic table. it attracts electrons like he attracts 13-year-old girls. Still really creepy, and I'm sorry for making you think about that repeatedly. And polar bonds are the reason for life, water being good at dissolving ions, water being good at dissolving polar things, and why water doesn't mix with oil. Do you want to know why? Because oil is nonpolar. There's your answer. Done. Alright, so I'm going to tell you guys about one of the reasons why polar bonds kind of are polar. It's the ability for an I got ahead of myself.